18 and 19 today. If you guys can have a highlighter and then perhaps two different colors, either a different color and then a pencil or just two different colored pens, that would be nice. It just is easier to refer to different things in color today. It makes it easier to visualize these things. Okay, so these are theorems on what we will eventually call the midsegment of a triangle, as well as multiple parallel lines. So for example, we're going to start with the parallel lines. With the highlighter, I'd like you guys to highlight parallel lines today. So let's say you guys were given 3 lines that are parallel. And remember, like when you guys are talking about parallel streets, they don't have to be spaced apart evenly. Most of the times when we draw them, we do, like if we draw multiples, we tend to draw them spaced out together nicely. But in these particular instances, we're going to actually make the assumption that they're spaced apart evenly. And the way that we know that is that on the left-hand side in a different color, I'm kind of using brewing colors and barren colors here, but the yellow and the blue are going to be things that were given to each other or given to us on the problem. So in this case, you guys have 3 parallel lines. We know that they're evenly spaced apart because it's given to us that AC is equal to CE. So kind of think of that transversal as the measurement of the distance between the parallel lines. And the fact that if AC is congruent to CE, those parallel lines are spaced evenly across. Now, if you guys follow those parallel lines over to the other transversal, then the assumption that you guys can make from this theorem is that BD would then be equal to DF. So in my third color in red, that's going to be that's going to be my conclusion, is that on that second transversal on the right, that those segments are congruent to each other. And so it's nice to have the highlighter because sometimes your parallel lines aren't in the same direction as it was in that diagram. So in example 1, just referring to the figure here, you guys have your 3 parallel lines are given to you as these that I'm highlighting. So go ahead and highlight those parallel lines. And you guys can see that the transversal that you're given information on, which I'm going to, again, do in my brewing color blue, is down below. And we know that that's given to us because we're given that MS is congruent to SY. And that's simply to say those parallel lines are spaced nicely and evenly apart. Okay, so then if that's true, our conclusion is going to be on our transversal. And our transversal is that this is, that NT is congruent to TZ. Okay, so that's just how you would read these diagrams. So let me give it a minute. I saw some people ask what page it was on. And what I'll do is have you guys type into the chat for some of your responses to the questions below. We're not going to do all of these, but let's say we do number 2. Okay, so we're going to go ahead and do our highlighting. We're going to highlight this time. They give us 4 different parallel lines. We know that they're evenly spaced apart because the transversal on the left, you're given AB is equal to BC is equal to CD. Notice that that gives you guys 3 segments. And that means that over on the right-hand side for your second transversal, your conclusion is that since those parallel lines are spaced evenly apart, that each one of those segments are congruent. So for question 2 in the chat, can you guys tell me how would you answer how to solve for X if you're given PQ and Q expressions for PQ and QR? What do you guys do with those 2 expressions? What do you guys do for those 2 expressions for number 2? Good, coming through on the chat is that we would set them equal to each other. Perfect, that is what you guys would do since they're congruent. You guys would set them equal to each other. Can you guys go ahead and do so and then type into the chat what the answer is for that equation? Catalina? All right, so if we subtracted the 2x, we get x. If we add the 9, we get 7. So very good. I see x equals 7 as the response. Okay, very nice. X is equal to 7. Okay, some people had some difficulties with 5, so we're going to talk about 5 next. For number 5, this time they tell you that PS is equal to 21. PS being this is equal to 21. What is RS equal to? If PS is equal to 21, what do you guys think RS is equal to? Go ahead and type into the chat. Wow, you guys are on it. So I think not a single one of you guys put some of the other responses that I saw in the other periods. So 7 is the correct answer. The reason is if you guys look at what I marked in red, there's 3 congruent segments here, PQ, QR, and QS. If all 3 of those add up to 21, that would give me 3x is equal to 21. So each one of those segments is equal to 7. So 7 is the correct answer. And I think some confusion from the last class, I didn't even think of kids thinking of it this way, but some of them counted the number of dots in between, which is incorrect. They thought it was 4, or they divided it by 2 to get 10.5. That's also incorrect because each one of these segments, there's 3 of them that make up 21. So it should be 21 divided by 3 or 7. Okay, the last one we'll do is, which one was the, 6. So if you guys take a look at 6, in 6, this time they give you guys that PR is equal to 7x minus 2. So let me mark that off for you guys. This is 7x minus 2. And that RS is equal to 3x plus 4. Okay, so if you guys look at PR, you'll notice that the length of PR is twice as long as the length of RS. There's 2 times as many x's as there are for this one. So what I can do is if I always think whenever it's related like that, which one should I double? Okay, should I double the bigger one to get this one, or should I double the smaller one to get that? Okay, so the equation that I'm going to set up is that you would double the smaller one. So that means 2 times 3x plus 4 must be equal to the bigger one, 7x minus 2. So double the smaller one to get the bigger one. Can I have you guys solve, and what do you guys think you get for x for that one? Okay, someone asked, what are we doubling? Where if you look at the actual segment itself, RS is half of this one, right? So we would have to double RS. So I took 2x plus 4 and I doubled it up above here, 2 times that, because it's the length of it, you would have to double it to get it to equal 7x minus 2. There's 2 of them. Okay, so the correct answer is x equals 10. There's some of you guys that got 6. So if I distribute 2, I get 6x plus 8. If you guys subtract the 7x, you guys get negative x is equal to, subtract the 8, you guys get negative x is equal to negative 10. So the correct answer is x equals 10. Not sure where you guys got 6 from. Some of you guys got 6. You guys can double check and look at your answers again. Any questions on that before I move on? Okay, so if we take those concepts and you simply, like if you think about this figure that I have with parallel lines, if I end up just extending those transversals and making a triangle out of that shape. So if you guys can all look at your screen at my cursor, if I just make that those 2 transversals meet at a vertex up on top, then what we do is we can transfer what we just learned into statements that we can say are also true with triangles. Okay, so with the given triangle below here, we're going to do the same thing, the same process. We're going to highlight our parallel lines. Okay, this segment right here that you're given that cuts across the middle of your triangle right there, one of the parallel lines that cuts off the middle, so again, I'm referring to MN, that's got a special name. It's called a midsegment. It's a segment that cuts across the middle of the triangle. And so that midsegment is similar to your parallel. So if we compare these two, you've got two parallel lines, and then the sides of the other sides of the triangles are your transversals. So again, Bruin color or Barron color in blue, I'm given that they're equally spaced apart because of these segments right here. Okay, and then on the right-hand side, you guys are going to make your conclusion, and your conclusion is that if they're equally spaced apart, then xn must be congruent to nz. Okay, so we're transferring our knowledge from the parallel lines above to triangles. And so if I carry this down, and let me know if you guys need time to copy down what I just did. I shrunk it so you guys can see both. Okay, if you take that information, and then what they do is they make it a little bit more interesting by throwing in more mid-segments. Okay, and some of them are truly mid-segments and some of them aren't, and it's up to us to determine if they are or not. Okay, so if you guys look at the diagram on the next page, okay, on the diagram on the next page, what we're going to do is highlight the two sides that are given as parallel. Okay, so we have a mid-segment that's MN, and then we have the bottom is parallel because of those arrow markers. And then in Bruin color, your transversal happens to be given that AM is congruent to MB. So our conclusion is a couple things, like you know then that M is the midpoint. If those segments are equal to each other, AM is equal to MB, then you know that M is the midpoint. What you're going to do after that is follow the mid segments to the other side. That's going to give you guys the other transversal, and across the other transversal, you now can conclude that AN is equal to NC, and that N is therefore a midpoint. Okay, so I'll do the first problem with you, number 8. Let's say I take my highlighter and I highlight the two parallel lines, one of which is the midsegment. I find the midsegment, which is in the middle of the triangle, and I see that they do tell me, in my Bruin color, they do tell me that this transversal, that C is the midpoint because I know 6 is equal to 6. So the question is, name all the points shown that must be midpoints of the sides of the triangle, of the large triangle. So I know C for sure is a midpoint. If I follow that midsegment across to the other side, A also must be a midpoint. Okay, so C and A are the only ones that are midpoints. I can't determine if B is or is not. Okay, there's not enough information. Okay, can I have you guys do the same thing? Go ahead and highlight your parallel lines. And in the chat, can you guys tell me what 2 points are the midpoints on number 9? What 2 points must be the midpoint? Okay, so find the midsegment, and it's basically the endpoints of the midsegment. So the midsegment is the one that cuts across the middle of the triangle. So B and C are your midpoints. So if you follow that midsegment across the way, then you can conclude YC is equal to CZ. You don't have enough information about A. Okay, so let's try that again. So pretty good job, those of you guys who got number 9 correct. Why don't you guys go ahead and highlight your parallel lines and find your midsegment and tell me which one must be the midpoint. And we're on number 10 still. We're on number 10. Okay, good. All the ones coming through are the endpoints of the midsegment, which are, if we know B is going to be on my Bruin color transversal here, 3, 3, then we follow that across to A, and A and B are going to be the midpoints. Okay, so what we do is we take that information, and what if we switch it around? We call it the converse of what we know. So let's say this time they give you 2 midpoints. They tell you in the box below that M is a midpoint. And I know that because they mark these off as congruent. Okay, they also tell me that we know that xn is equal to nz, so therefore n must be the midpoint. And so my conclusion is going to be on the fact that if those are going to be the midpoints, then I know that mn is going to be equally spaced apart from yz. So that mn is parallel to yz. So that's going to be the first thing you guys can make the assumption on. So if m and n are the midpoints, so it's kind of the converse of the above. If m and n are the midpoints, then those two lines are parallel, as well as, this is new, okay, as well as the fact that mn being the midsegment, mn is equal to half of yz, of the base of the triangle. So if you look at the picture, mn is shorter than yz. The relationship is that if you double mn, you should get yz, or if you take half of yz, you guys should get mn. Okay, so what I do is, let's say I'm given a picture of, actually we'll do the example below that. Okay, so if you guys look at the example below that, you have M is the midpoint of yx. Sorry, I'm on number 11 and 11 through 14, that diagram. We're just going to jump into those 4 examples. Okay, you guys have M is the midpoint of xy, and N is the midpoint of xz. What is your conclusion? So in red, if I know that those are the midpoints, then I know that these lines are equally spaced apart. Okay, and then the other relationship is that mn, which is the shorter one, mn is equal to half of yz, is equal to half. The midsegment is half of the base. Okay, so let's answer some questions. Let's say this is all true, 11. If mn is equal to 6, what is yz equal to? And mn is shorter, right? Physically speaking, it's shorter. So if mn is 6, what is yz equal to? Okay, very nice. So you guys went from something shorter to something longer, so you doubled it. Okay, nobody put 3, so that's good. So it's 12. Physically speaking, yz should be longer than mn, so you double. Okay, for the next one, if yz is 20, what is mn equal to? Go ahead and type that into the chat. Okay, so this time we're going from the base, which is longer than the midsegment, so we're cutting it in half, so we get 10. Perfect. Okay, for 13, this time they tell you that mn is x and yz is 3x minus 25. So if they're related in the sense that they're half or doubled, if I want to set up an equation to make them equal to each other, what I'm going to do, it's easier to double something than it is to take a half in an equation. So I'm going to pick the short one, and the short one in this case is x, and I'm going to double that because mn is the midsegment. So if I double x and set it equal to 3x minus 25, then I get an equation that I can solve. So very good. So can I have you guys solve for that and tell me what is x equal to? Okay, Kara, that's fine. All right, good. So I see the ones coming through. If you guys were to be careful with signs, it should be positive. If you guys were to subtract 3x to the other side, you get negative x equals negative 25. So x therefore is 25. Very good. Some of you guys went on to answer. If mn is x, what is mn equal to? Well, that's 25. If I plug 25 back into yz, you guys get 3 times 25 minus 25, which should lead you guys to 50, or you guys could have just doubled, right? We know that relationship as well. Doubling 25, I would get 50 for the base. So very nice on that. Our last question, if you guys have that, your conclusion is that these lines are parallel, then, and they give you xmn as 40 degrees, Can you guys type into the chat, what type of angles are XMN? And the question is asking for XYZ. How are these angles related to each other? If you guys can give it a name as well, let me see if you guys remember, because we haven't talked about these types of angles in a while. If you put same side interior angles, are they on the inside of the parallel lines or not? Okay, so good. The answer is their corresponding angles. And if they're corresponding angles, then they're congruent, right? So that angle must be 40 degrees because of corresponding angles of lines that are parallel.